So again, we're talking about one of your homework questions that gave you this function y and asked you to find the rate of change of y with respect to x at x equals 4. So then when you look at this, what comes to mind? When you look at this function y equals x f of x, it's a product, right? So, and the two functions involved are x and f of x, right? And so if we use the product rule to find the rate of change, well, the product rule tells us that the rate of change is the first times the derivative of the second plus the second times the derivative of the first. What's the derivative of x? 1, right? So times 1. Okay, and so then after you've done this process is when you actually start plugging in values. So then this rate of change function evaluated at x equals 4 is 4 times f prime of 4 plus the function value at 4 times 1. And then at this point is when you would go to the table. There was a table of values where you could read off what the rate of change of f at 4 is and what the value of the function at 4 is. So something to take away from that, just like surface level, is the fact that those are oftentimes different, right? So the function value versus the rate of change of the function value, those are oftentimes not the same number. And that's what made the function e to the x so special, right? Is that its function value and its rate of change function value gave you the same numerical value at every instance of x. Okay, so that's what made that function special. But in general, that is not the case. And so that's why when you had this homework assignment, the table had two different rows for values of f and values of f prime. Okay? All righty. So then, hopefully you've gotten the idea from all of my postings on Blackboard that this mastery test is a big deal, right? So it's worth 6% of your overall grade, and it would be fantastic if every single one of you passed it on the first try, because that means less grading for me, okay? And I'm so serious about that. It's like my least favorite thing to do as part of this job. So if you could all study really, really hard and make sure that you pass the mastery test on the first time, then we will all be happy, because if you pass it on the first try, that means you get 100% on the mastery test, right? So 90% is 100%. And you can just bank on those points in your final grade, okay? So it's super awesome. Let's all please go for that. The format of the test is 2 parts. So the first part is going to be what I call simple derivatives, okay? And then the second part is going to be the more complex derivatives, okay? This is a purely memorization, plug and chug type of test, okay? This is a requirement from the department for this course to, yeah. So that's what we're going to do. And so today, I'm so sorry. I really am trying, guys. Okay, so today what we're going to do is we're going to practice with some simple derivatives so that you can get a feel for that, and then we're going to talk strategy about the more complicated ones after that. So here is a sampling, if you will, of what I mean when I say simple derivatives. So go ahead and bust out a piece of paper and maybe take a few minutes to work on your own. Now, if you don't have all of the rules memorized, this is a good time to challenge yourself. But if you don't have them memorized, it is okay if you want to pull out the list that I posted on Blackboard of the summary list of all the rules you have to memorize. And if you need to use that for today, okay. But just remember, by Thursday, you need to be able to do these without that list, okay? So take a few minutes and try to knock out these, 17 derivatives. This is rapid fire. Just go for it.
Okay, we work from here.
Yeah.
I'm so
There's an
fine with that
open
one.
seat right there, too, if you want to sit down. So, the biggest issue I saw just now was not about your calculus knowledge, it was about your rules of exponents knowledge, okay? So you can make your life super easy by remembering some of these rules of exponents. Keep them near and dear to your heart, okay? So namely, they're going to help you rewrite functions in a form that we can apply our rules for, okay? So I talked to some of you already about it, but in particular, the problems on this list that I'm referring to are numbers 2 and 15. If you choose to rewrite those using exponents, the problem becomes incredibly simple, okay? So in particular, I can write the square root of x cubed as x to the 3/2, okay? So I'm not taking a derivative yet. I'm simply rewriting the original function, okay? But now that it's in this form, it's of the form x to the n. So finding its rate of change is now a half-second process, right? What is the rate of change of x to the 3/2? So the rate of change is 3/2 x to the 1/2, right? You subtract 1 from the exponent, okay? So let's do the same thing over here. So for 1 over the cube root of x squared, how could I rewrite the original function? X to the negative 2/3. Beautiful. Okay? And so then if I want to find the rate of change of x to the negative 2/3, I can again apply the power rule. Thank you. So negative 2/3 x to the negative 5/3, right? Super easy once you rewrite it. Okay? If you don't rewrite it, then you're stuck doing possibly quotient rule and chain rule twice, and it just gets really ugly really fast. Okay? So try to do yourselves the favor of rewriting whenever possible so that things look nice. Okay? The catch is, though, if you rewrite the original function, don't forget that that's all you're doing. You haven't actually taken a derivative yet. Okay? So if there's one thing that I've seen students do more often than not, it's making the mistake of rewriting and then thinking they're done. But all you've done is rewrite. You still have to actually do the calculus part now, okay? Other things to draw your attention to. Number 8, I saw some people trying to apply the rule that the rate of change of e to the x is e to the x to number 8. So there's a problem here because this e to the x is a function of x, right? E to the x takes in values of x and spits out corresponding values of e to the x. E squared, however, is a number, right? E raised to the second power is just a number. You can type it into your calculator and it'll give you an approximation, okay? So if I want its rate of change, what is that? 0, right? The rate of change of a constant is 0. Should I write equals 0 like this? No, right? E squared is not equal to 0. So I'm also drawing your attention to this because it will cause me great pain and agony if on your mastery test you start writing that the original function equals the rate of change. Because remember, that only works for one function, and that function is e to the x, okay? So please, please don't say that your derivatives equal the original function. They don't, okay? So don't write this, right? Say this, okay? Or d over dx, or any of the other possible notations, okay? Let me see. Other tricky ones? Are there any other ones that you guys want to talk about? 13? Where's 13? E to the 2x. Okay, so e to the 2x is not e to the x, right? What's different about it? It's a function inside of a function. Good, okay? So I'm plugging 2x in for x in the e to the x function, okay? So this is, in fact, a composite function. So we should use the chain rule, okay? And so again, I'm not going to write that this equals something because this doesn't equal something. However, its rate of change is equal to 2 times e to the 2x. So this is using the inside out version of the chain rule. If you had written e to the 2x times 2, that would be the outward in version, and that's fine as well. If you ever get, I don't know, I'm just going to say this because this is how I used to teach it, and people seem to like it. So if you like it, great. So I always say the derivative of e to the stuff is e to the stuff times the derivative of the stuff. Okay, that's the chain rule applied specifically to e to the x. Okay, and likewise, the derivative of natural log of stuff is 1 over the stuff times the derivative of the stuff. That's the chain rule applied specifically to the natural log function, right? So if you get confused by the chain rule and labeling inner and outer functions, then think of it as like cosine of stuff, sine of stuff, natural log of stuff, right? And then remember that it's the derivative of the outer thing of the stuff times the derivative of the stuff. Okay, it's kind of weird. If you like it, cool. If not, then I only took 10 seconds of your time. Okay. Any other ones before we move on? Number 3. Number 3 is 2 times the natural log of x, right? So I've got a constant times a function. So the rate of change of a constant times a function is the constant times the rate of change of the function. So what's the rate of change function for natural log of x? 1 over x. Okay? And that's it. Okay? All right, so expect a list of about 25 of these on your mastery test. 4 and 5? So 4 uses the rule that the rate of change of a to the x is a to the x times natural log of a. So in this case, a is 5. So the rate of change is going to be 5 to the x times the natural log of 5. And then this one uses a similar rule for the rate of change of log base a of x. Does anybody have that rule out? 1 over x natural log of a? Is that, okay, cool. So then that means that the rate of change of this function is going to be 1 over x natural log of 9. Okay, because the base here is a, or is 9. A is 9. Okay. All right. So we spent a lot longer working on the simple ones than I thought we would, but that's okay because it's good practice. Now the trick is that you're going to have 10 more complicated ones. Okay, and those 10 are going to come from this list. Okay, so no excuses, right? So between now and Thursday, you will master all 48 of these because 10 of these will be 10 of the problems on your mastery exam. Okay? And no, I will not be posting solutions because you know how to get the solutions. How do you get solutions? Graphing calculator. Also, FYI, if you don't have time to come see me or Mark, or if recitation isn't enough practice, the tutors in the tutoring center can help you with this. Okay, so this will be the 1 week of the semester where you can absolutely go to anybody who claims to know anything about calculus. They should be able to help you with these. Okay. All right. So the advice, though, when tackling these more complicated things is to, again, look at the function structure, the overall structure, so you can figure out your game plan, okay? So is it a product? Is it a quotient? Is it a composite function, okay? And then figure out what the subfunctions are, and then if you're going to have to apply any other tricky rules to those subfunctions, right? And then, like, keep all of your work organized, and then put it all back together, okay? So what do I mean by this? Okay, so if I give you a function that looks like this, okay, sort of the novice approach would be to look at the little parts and be like, oh, I see a sine of x, and I see a cosine of x, and an x squared, okay? That's not going to get you very far, okay? The way that you should try to train your brain to look at this is to say, no, 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 okay? I've got a really complicated looking function here, and its overall structure is of a product, okay? So once you've identified that it's a product, now you can start zeroing in on the smaller pieces, okay? Because once you have a product, you can say, okay, well, I'm going to apply the product rule. And I've got these two pieces. The 1 minus sine x over x squared is my first function. And then e to the x over x squared cosine x is my second function. And so I know that the overall rate of change of g is going to be the first times the derivative of the second plus the second times the derivative of the first. Okay? But then you realize, oh, shoot, the first and the second are pretty complicated, and I'm going to have to use some other rules to find the rates of change of those. Okay? So the plan is going to be product rule, but within the product rule, I'm going to have to use the quotient rule, which will also invoke the sum rule and power rule for the first one, right? And then for the second one, I'm also going to have to use the e to the x rule and the product rule, right? And I'm going to have to remember some trig, okay? So there's a lot going on here, which is why it's really important that you plan your work carefully, okay? I'm trying to think. So we have about 8 minutes left of class. Shall we tackle these two examples? Okay. So I've already given you a game plan for the first one, g of x. So go ahead and take a minute to work on g of x. And then if you get done with that before I start talking again, try h of x. Okay, it pains me to stop you because you guys are working so hard, but I think it will literally take me the next 3 minutes to write down the solution. And I don't want to send you out of here without the solution. So let's finish it together, okay? So remember that we have here a product, right? G is the product of this first function and times the second function. So the rate of change is going to be the first times the rate of change of the second, okay? And so in order to find the rate of change of this function, what do I need to do? All right, so this is a quotient, and so I need to use the quotient rule, which says low d high, right? So the derivative of the top is e to the x minus high d low. Okay, but the derivative of the bottom, what do I need to do in order to find that? This is a product, right? It's x squared times cosine of x. So notice, sometimes saying the functions out loud helps, right? Because, you know, when I say this bottom function, I have to say x squared times cosine of x. Multiplication. This is a product, okay? So the product rule, again, is the first times the derivative of the second, which is negative sine x, okay, plus the second times the derivative of the first. Good. Whew. So that was, remember where we are, that was low d high minus high d low. Draw the line and square below. That's the first term, okay? So then we have to add the second, right? Because remember, we just did the first times the rate of change of the second. So now I have to do plus the second times the rate of change of the first. Oh, but that's a quotient too. So we're going to do it all over again. Oh, question? Where? Here? X squared times negative cos? So this is using the quotient rule. This is the low, and then times the derivative of the top, minus the top times the derivative of the bottom. Okay. So all right, so we were taking the second times the derivative of the first, and the first is a quotient, but at least the bits are a little bit simpler. So again, we do low, d high. So what's the derivative of 1 minus sine of x? So I'm going to write it out in excruciating detail because I saw some people struggling with this a little bit. 1 minus sine of x is not, as a whole thing, something that you should memorize, right? It is a sum or difference of two functions, right? So its rate of change is the difference of the two rate of changes, okay? So the rate of change of 1 is 0 minus the rate of change of sine of x is cosine of x, okay? So this was low d high minus high d low, 2x. Draw the line and square below. Okay? That's the final answer. Please do not simplify, okay? This is how I want to see your answers on the mastery test on Thursday, okay? If you do any simplification to this, I'll get mad. So don't do it. Well, okay, fine. If you do x to the 4th, I will live with that. Okay. And you can leave out the 0. Okay. So I think that's all we have time for today. You've been wonderful. Study hard. Remember, if you pass it on the first try, you get 100%, and we can all be done with it. Yes. It's on Thursday. Anytime. It's the normal testing procedure. So you're going to the testing center. You're going to bring your student ID sometime between 10:30 and 6:30. No calculator, no note cards. You don't need it. It's going to be just like this. Okay? Hi. Let me stop the recording, and then we can take care of the attendance.